Hey everybody, MS Farzan here, and welcome back to this video series on how to make a 2D multiplayer tabletop card game using Unity and Mirror. In our previous session, we learned how to use our Draw Cards button to instantiate a bunch of cards in our player area and move them around and parent them to the canvas so that they stay on top when we're dragging them around. Now we need to do a little bit of work on our player area and also our drop zone so that they so that when the cards are instantiated or created, they will have a bit more space between them. They're not being instantiated one on top of each other, and also so that when we drag and drop our cards, we can't just put them anywhere on our screen. When we drag a card, it should go in the drop zone if the player has dropped them correctly, and if they haven't dropped the card correctly, it should return to the original parent, which was the player area. That requires a little bit of setup, both on the UI or the user interface side of things, and also on the script side of things. So let's get started with that. The first thing I'm going to do is select my player area prefab, and I'm going to begin working with what's called a grid layout group. So I'm going to add a component. I'm going to search for grid layout group. And that creates an invisible grid here that is going to govern how things are going to work when they're children of that game object. I have a few things that I've already worked out here on the back end, so I'm just going to let you know what has been working for me. You're welcome to tinker with these things in your own time and see what works for you. Here I'm going to make the cell size basically the same size as my cards, which is going to be 120 by 177. I'm going to have 20 pixels on the x-axis in between these, and 0 on the y-axis. I want the start corner to be the lower left. I want the start axis to be vertical. And I want the child alignment to be middle center. And the constraint to be a fixed row count with a constraint count of 1. We'll see a little bit of how this governs the shape of how the cards are going to come out, but that's not really important at this time. Like I said, it would be a great idea to just play around with these different values and see if you find something that works better for your game. This is just pretty simplified for our purposes. We'll need to do a similar thing with our enemy area, which is a great reason why you basically just want to make one version of a thing and then make like prefab variants or just like duplicate the prefab. But this is we're doing this sequentially so that you're able to see each one of the steps. So our enemy area will also add a grid layout group. We'll use the same items here, so 120 by 177, 20 pixels in between them. We want lower left and vertical and middle center and a fixed row count of 1. And we'll do the same with our drop zone. Add a grid layout group. These are all basically the same thing, different colors, which is why we could have just duplicated them, but what are you going to do? 177, 20 pixels, lower left, vertical, middle center, and fixed row count of 1. I think this probably makes no sense right now, but it will. Let's just see what happens when we draw our cards. Okay, now we see that rather than drawing the cards and putting them one on top of another, it's utilizing the grid layout group to space them out with 20 pixels in between them. And I would think that the first one starts in the middle and then it populates out to the left and right. I'm not actually certain about that, but we'll see in just a moment with the drop zone. And so that looks pretty good. You could change this as you like and move them however you like. Like it's all the same to me. But the point is that they're now displaying correctly as a hand of cards. And when I draw them, they will because this card is now a child of the canvas and no longer a child of the player area. It works to my advantage in that the hand size will get smaller, and I can keep doing that, and that's just great. Now there's no other added functionality here, just that part of it. I can't reparent it to the player area without having the appropriate script. So we're going to work on that now. Okay, so looking at just pulling up the right scripts here. Looking at the script here for the drag and drop, I need to say something here that indicates if the card is dropped in a drop zone, like that's fine. But if it's not, it should be sent back to the player area. That's going to require a couple of steps on our part. The first thing we're going to do here is we're going to declare a public game object drop zone. And similar to what we did here with the main canvas, in the start method, we're going to say drop zone equals game object dot find drop zone, which is what we've called it in our scene here. You're going to have to make sure that your spelling and capitalization spacing is all correct. Otherwise, it won't be able to find the right game object. And then in the what we want to check is in the start drag, we want to say that the start parent we haven't actually declared these. Let me just make sure that I do this right and tell you the right thing. We're going to say we're going to create a private game object start parent, a private vector2 start position, and a private game object drop zone, and a private boolean is over drop zone. Let's look at in turn what each one of these are going to do. Within the start drag, we basically want to store where the exact position or the parent of the card before it goes anywhere. And so within start drag, when someone starts to drag this, we're going to set start parent equal to transform.parent.gameObject. This is shorthand for saying the transform attached to this game object. We want to find the parent of that transform and find that game object and say and make that game object equal to the start parent. So the parent here is going to be the player area. You could do this with transforms as well. We're just using game objects here. It's not that big of a deal. And we're saying start position equals transform.position, the position of this transform before it gets dragged. We want to store that. And in the end drag method, when the game object is when someone stops dragging the game object, we want is dragging to be false, and we say if is over drop zone, do something. Otherwise, transform dot position equals start position, and transform dot set parent start parent dot transform false. So when the card is when the end drag happens on the card, if it's over the drop zone, let's do something, which we'll handle in just a moment. Otherwise, send it. Make the position its start position, which we stored when we started dragging, and set its parent to whatever the parent was at the beginning of the drag, which in this case was the player area. And we say false because we don't want the world position to stay wherever it is when the person's dragging it. We want it to go. We want to parent it to the start parent and make sure that its position is relative to the start parent. You might say, well, why do we have to set the parent again? Well, that's because when we're dragging, we change the parent to the canvas so that it's closer to our eyeballs, and we need to send it back to wherever it came from. In this case, it's the player area. So what do we do if it is over a drop zone? Well, we'll say transform dot set parent lowercase drop zone, and we'll see why in just a moment, dot transform, comma, false. We don't want it to keep its world position. We want it to be right in the middle of the drop zone. And that's it. Great. Something pretty huge is missing here, but which we'll discuss in a moment. But the general logic is that when we start the drag, we want to store the original parent and the original position. When we end the drag, if it's not over a drop zone, then we send it back to from whence it came. If it is over a drop zone, set the parent to our lowercase drop zone. Now, why are we using lowercase drop zone instead of the uppercase drop zone? Well, there's a couple of reasons for this. The first one being that we need to set the position of the exact drop zone that we're talking about at a very specific moment in time. So, and the way that we're going to do this is by using colliders, and that's generally the only like 2D physics adjacent stuff that we're going to be using in this tutorial. There are some other ways of doing this, like you can use raycasts. This is just the simplest and, in my mind, most elegant method that I've come across in making this work. If you find a better way, like, you're welcome to use it. I've seen a couple of examples. This is the one that seems to work the best for me and in the most use case scenarios. Let's go back into our scene and hook this all up. I have my cheat sheet on another screen here. So what I need to do is go to my card 1 prefab, and I need to add a couple of things here to make this work. The first thing I need is called a box collider 2D, and I also need a rigid body 2D. The box collider does exactly what it sounds. It creates a collider that detects when there's a collision between this object and another game object. And the rigid body allows us to have 2D physics stuff performed on the game object. The thing that I want to show you here is that if I double click this card prefab, I get a closer view of this actual prefab. And then when I click on the collider, I can click Edit Collider, and it shows me this little green thing. That just means that that's the size of the collider. I want the collider to be the size of the entire game object. So here under I don't really need to change anything except for the size. I'm going to change it to 120 by 177, and that makes a pretty much size of the card itself. I could use these little handles to edit it as needed if I wanted. And it's a box collider rather than, like if you had different size types of cards, like circular ones, you probably would use a different kind of collider. And then for the rigid body 2D, I'm going to keep it as a dynamic and simulated and all this business. The only thing that I need to do here is I'll change the angular drag to 0 and the gravity scale to 0, because I don't want the card to have any gravity in my scene. I just want it to be an item that detects collisions, but isn't like pulled down to the edge of the screen or something. And collision detection will be continuous. And that's really all the changes that I need to make. Now, if we were doing this smartly, then we would have just one card prefab that would change all, variants of that prefab. We're doing this so simply that it does require for us to do a similar thing here in card 2. So we'll just do that. We'll add a box collider 2D and a rigid body 2D. We'll make this size of the box collider 120 by 177. And we'll make the angular drag 0 and the gravity scale 0. Collision detection will be continuous. Okay, so that should work for all of our card objects. Great, so they will now collide with one another. And then we'll take a look at our drop zone. And we also need to create a box collider here. We don't need a rigid body because we're not actually performing physics operations on this thing. So I'm going to add a component here, which is a box collider 2D. And then here, the size, I'm just going to set it to, what is the size of this thing? Well, let's take a look at the actual collider. Should be 1920 by 195. Okay, and we can see that lines up pretty perfectly. Does that look right? Just checking my cheat sheet. Collider, yep, that all looks good. Great. Okay, cool. So what this means is that we've created a collider on the drop zone as well as the cards. So when those collide, we should see a collision. Let's demonstrate that through the code. So we've got our code up here. And the way that we access our collisions through code is pretty simple. We're just going to add a little block here that says private void on collision enter 2D. And we'll create a little block here, and then private void on collision exit 2D. Let's just say debug log colliding and debug.log uncolliding. I find this to be a really great way just to make sure things are working as you might think they're intended. If you run into an issue, just debug log something and see if it's working the way that you want it to. And now let's go back to our scene, hit play, draw cards. We don't see any logs here. I'll go to the console and I draw the card and it says it's colliding. It's colliding. See how many times it's colliding and uncolliding. And then let's collapse this so that we only see, we can watch the numbers go up here on the right hand side. And I drag and it's colliding. It's colliding. Great. And well, it's being sent back to the parent, the original parent, the player area. But something I want you to notice is also it's when I go over these cards, they're also colliding and kind of like starting to look weird. See the numbers go up on the right hand side? That means these cards are colliding with one another too. So we have a couple issues here. One, we can't really drop the card anywhere. It just goes back to the parent, which we want that. That's cool. But we need to write our code to make sure that it's parented to the drop zone. And we also need to make sure these cards don't collide with one another. How do we do that? Well, it's actually a little bit easier than you might think. Or maybe not. Maybe it's complicated. In the first case, we'll say on collision entered 2D, when this happens, when it collides with something, this card collides with something, we'll say is over drop zone equals true. And the drop zone, lowercase drop zone, is equal to collision dot game object. So whatever it's colliding with, we're going to say lowercase drop zone is equal to this, to whatever collision is being passed into this by Unity. So when a collision happens, Unity passes in the event of the collision into this script, and we're accessing the game object that it's collided with, and setting that to the drop zone. We're saying whatever you collided with, that's probably a drop zone. So let's make it that. And then on collision exit 2D, when the collision doesn't happen anymore, we'll say is over drop zone equals false, and lowercase drop zone is equal to null. And that just resets everything back. This could be like if you have multiple different drop zones and you want to, govern your logic within this script. That's what you could do here. Nothing needs to happen within our start drag function, but within our end drag function or method, we said that if it's not over the drop zone, if this boolean is false, then we send it back from whence it came, that's working properly. But we see here that if it is over the drop zone, we want to set its parent to lowercase drop zone, or the transform of lowercase drop zone. And so now that we've done all this, that should work properly. Let's give it a try. Okay, hit play. Oops. Hit play. And then hit the draw cards button. And all of these cards populate. I drag one of these cards over to the drop zone, and it drops right there. But it's kind of like, what's happening here? It's like it's being all weird. And then I drag it, and it drops over one of these cards, and there's collisions, and like weird stuff's happening, and it's just all a hot mess. Okay, so that's problematic, but it's kind of working right. And so we need to get a little bit into the layers and the layer collision matrix. No big deal. First of all, when I click on one of my cards, I see that the layer is default. I'm going to add a layer here, and I'm going to call it under user layer 6. I'm going to call it cards, and another one that's called, let's say, drop zones. Okay, go back to my card. I'm going to set that to cards. I'm also going to set card 2 to cards. I'm going to grab my drop zone, and I'm going to set it to drop zones. Okay. Now I'm going to go up to edit project settings, and I'm already in my physics 2D menu. You might have to scroll down to see this based on your screen. And I see this layer collision matrix. That means allows the configuration of the layer-based collision detection. That just means right now we have it set so everything collides with everything. But what if I don't want cards to collide with themselves? Well, I just find where cards are colliding with themselves, uncheck that box, and now cards will no longer collide with themselves. However, drop zones will collide with drop zones. I don't think we need that, but we do want cards to collide with drop zones. That's in our layer collision matrix. Now I hit play, and I hit draw cards, and nothing weird happens. I don't get any sort of weirdness there. I drop it in the drop zone, and I do see a little bit of weirdness there. It's starting to just like shake and bake like that. And then I don't drop it in the, I don't let it collide, let's say. I drop it here, and it goes back to its original parent. Let's take a look at why this is happening here. Well, the reason is there's just a little bit of hinkiness with the way that the box colliders will work, or I should say the rigid bodies attached to the cards. There's a tiny thing here under constraints that we want to use, where whenever we manipulate these cards with a rigid body 2D, we want to freeze the X, Y, and Z rotation, X and Y positions and the rotations of these game objects. Same with card 2. I don't know if this is a holdover from the fact that Unity at its heart is a 3D engine, and we're working with it on a 2D space with it. And so it's not like natively 2D like some other game engines. And so it might be some weirdness there. I'm not quite sure, but this works. This is what has worked for me, is to find the rigid body 2D component and change the constraints by freezing the XY position and the rotation. Now when I hit play and I hit draw cards, they all populate this way. And if I drop it in the drop zone area, it does so. Another one will do so. We'll just keep doing that. But if I don't drop them correctly, or if I try and drop them in the enemy area, they'll go back to the start area. And we'll see now that everything stays in the drop zone, and you might have a scenario in which you don't want the cards to be manipulated after they've been dropped there. We've done a great job at parenting them right, and it all works correctly, but you might want to say like, okay, I don't want you to be able to drag them anymore. We'll deal with that in a future video. And that pretty much wraps it up for our basic game architecture from a single player perspective. In the next video and the ensuing videos, we'll mostly be looking at the networking aspect of this with using Mirror. So we'll make it similar to the very first video in this series, where you're able to drag and drop cards, and then someone else on a different client will be able to see what you're doing, and vice versa. So that'll be cool. Be sure to tune in for that. And if you like this video, please be sure to physically like it and subscribe to my channel for more. You can also follow me on Twitter. And I'd love for you to check out my books and games. You can do so by following the link that I've included in the description of this video, and we'll see you soon.